Okay, sorry about that. You live and learn. When you get a phone call, it stops your recording. Okay, so back for part two. Anyway, so we're looking at average cost, and the average cost is found by taking the original cost function and dividing it by x. So we're finding out what is the average cost per unit that you are selling. Okay, now, because it's cost, what do you think we're going to try and do? Are we going to try and maximize our cost or minimize our cost? So the hope is that we're going to minimize our cost, or in this case, minimize our average cost. So let's look at what our function looks like here. So this says, find the production level that minimizes average cost per unit if C equals 400 plus 0.05x plus 0.0025x squared, where C is cost in dollars. Okay, so we want to find the production level that's going to minimize the average cost. So how many of whatever these things are we going to produce to get a minimum average cost? Okay, they gave us the cost function, which is why it's very important that you read that question carefully. So they want average cost per unit, which means this is not the function that we're going to deal with. We want C bar, okay, which means we're going to take the original function and we're going to divide it by x. Okay, so this is the guy that we're working with, not the original. Okay, now we're going to find the derivative, but I wouldn't do it here. Let's do some simplifying here. So that x, we could divide it on each one of those, and I'm going to make my life easier so I don't have to use the quotient rule. So I'm going to go here with this is 100x to the negative 1, right, over here. This time the x's are going to cancel, so it's just 0.05. Okay. And on this one, the x will cancel with one of those, so it's 0.0025x. So that's the actual function for average cost that will be easiest to take the derivative of. So now we'll go for the derivative. So we'll bring down the negative 1, so this will be negative 400x to the negative 2. That guy goes away, right? And that is just going to be 0.0025 there at the end. Okay. Now, in order to minimize this, we're finding that minimum, so we want to set it equal to 0 to find our critical value. So we'll say 0 equals, and at the same time I'm going to put this x squared back on the bottom. Squared. So we end up with negative, or sorry, no, it won't be negative. It'll be positive 400 over x squared equals 0.0025. Okay. All right, so if we multiply by the x squared, puts us over here, so we just need to divide out the 0.0025. Where's my calculator? Okay. So 400 divided by 0.0025 gives us 160,000 equals x squared. But then what do we need to do? We need to take the square root. So the square root here is going to be x equals plus or minus 400. Okay. But again, we're in a business application, so do we want negative 400 units? We don't, so we're gonna say X equals 400 units. Okay, so at a production level of 400 units, we're gonna come up with our minimum average cost. So average cost per unit, okay, will happen when you produce 400. All right, how are we doing? Looking good? Okay, so one more problem and then I will let you do this on your own, okay? This next problem that we're gonna do, hopefully everybody has this all written down, okay? This next problem we're gonna do is one of my favorite problems. I don't know why, I just like it. Okay, so I really like these types of problems. So, an orchard has 16 orange trees. That each yield 80 oranges. So obviously this isn't a very big orchard and it's not very many oranges, but we're just going with this because the numbers work out nicely, okay? So an orchard has 16 orange trees that each yield 80 oranges. Now, the owner wants to plant more trees. So the owner wants to plant more trees. But with each extra tree, the yield of oranges per tree will drop by how many? 4. How many trees should the orchard have to maximize, to not make, to max the yield? Okay, I don't know why I like these problems so much, but I just really do. Okay, so we're looking at maximum yield here. And this is definitely, for anybody that's in agribusiness, this is definitely an example that we want to look at. This is looking at orange trees. This could be vineyards. This could be the number of cattle you have in your herd. So there's lots of different ways to do this. But the idea behind this is that as you add more to your stock or your orchard or your plants or whatever it is, are you going to continue to get the same amount out of what you have? So in this case, they're saying that they can get 80 oranges per tree when they have 16 orange trees. But if they plant another tree, either because of space or because of water constraints, or maybe there's not enough time to harvest, what they're going to notice is by each extra tree they plant, their yield is going to go down by 4. So if they plant another tree, then they're only going to get 76 oranges per tree. So what we need to do is find the sweet spot to decide how many more trees should they produce or should they plant. And even though the yield's going to go down per tree, where's the sweet spot so they're going to get the most oranges out of all of the trees together? Okay, so definitely an important problem. Now, for yield, you can let it equal whatever variable you like, but I like just W for, Jesus, what is wrong with me? Y, that's a Y, okay, sorry, Y. Y for yield. And there's a particular way to go about this problem, okay? So the idea is that we're going to think of 2 things. We're going to think of trees and we're going to think of oranges. So in parentheses here, when we have 16 trees each tree gives us 80 oranges, yes? Okay, that came from the first line. Now, if we want that yield, we will multiply those two numbers together. Okay, but that's not what we're interested in here, okay? So we're not necessarily interested in that yield, because what we're gonna do is we're gonna start adding trees to the orchard. So we're gonna rewrite our formula, but I'm gonna make my parentheses a little bit bigger. So this is still trees, this is still oranges. Now we know that there are 16 trees for sure, but we're gonna start adding trees. And we don't know how many, so we're gonna say plus X trees, however many trees this is going to be. But here's the thing, when it comes to oranges, for each extra tree, so for each X tree, the yield is gonna go down by 4. So our 80 is gonna start subtracting 4 per tree. Okay, so if we plant one more tree, we're gonna lose 4 apples per tree for 76, okay? So this is the best way to go about writing the formula. Start with the original, then say, if I add to the original, what happens to the yield? So this is actually the yield function that we are interested in. Okay? But definitely FOIL this out, okay? Don't do this any other way. Just FOIL it out first and then take the derivative, and life will be that much easier for you. Let's see, what's 16 times 80? 1280. Okay, so FOILing this out first, we get 1280. Then we'll have minus 64x plus 80x minus 4x squared. So 1280, let's see, what do we have there? Plus 16x minus 4x squared. Okay, so FOIL it out, and then we're going to find the derivative of this guy. So the derivative of the yield, that's going to go away. That'll just leave us 16, and that'll be minus 8x. Okay. Now again, we want to find the max, so we need to set this equal to 0. So 16 minus 8x equals 0. So x is going to equal 2 trees. So they could keep adding more and more trees, but they're going to do the best if they just add 2 trees. Don't go past 2 trees. Even though it might be tempting, you're best off if you only plant 2 extra trees. Now, make sure you go back to the beginning of the problem, though. This said, how many trees should the orchard have to max the yield? So should the orchard have 2 trees? Or should the orchard have 18 trees? Okay, so remember, they're asking for the total trees. So 18 trees will max the yield. Right, so remember, after you've done all of this hard work, you've created these formulas on your own, and you do all this work, make sure that you answer. It didn't ask us how many extra trees, it asked us how many trees in total. So your answer makes sense with the question. Phew, okie dokie. So those are some optimization problems to help you out. So you can go ahead and work on the optimization, getting maximums and minimums, okay, by using the derivative. All right, and I will see you next time.